Okay, when we're talking about coal combustion, we're actually talking about coal pulverization. The coal needs to be pulverized to be able to burn in the boiler. So the main machine for that is the pulverizer itself. Now, each pulverizer can be characterized by three main points. The first one is the mass flow. How much can a pulverizer really do and throughput in 1 hour? How many tons per hour? The mass flow has a direct input on the power of the burner. And the second one, of course, is while it's pulverizing, it's also drying the coal. So the raw coal comes in with 10% moisture and we go down to, let's say, 2% moisture. Can the pulverizer do that within the limits of its design? And the third one, of course, talking about pulverization, is the fineness of the powder or pulverized fuel. The particle size distribution has an impact also on the mass flow. If you have more coarse material, you can grind more coal than if you have more fine material. So it all sticks together, and mass flow certainly is one big part of the whole equation.
Yeah, certainly the mass flow, because that's perhaps the dominant input. I mean, do we really know what we put into the mill in the sense of fuel air? Do we really know what we take out? And do we know that that which we take out is uniformly distributed to each of the burners? And if we can establish uniformity from burner to burner, we could then seriously think about matching mill to mill. And if at the same time we could maintain, say, a minimum velocity in the pipes such that we didn't get fallback of product and we don't have it lying like sand dunes in the pipes, then we'd be on our way to getting something like optimum efficiency.
Yes, but that's definitely an issue of airflow through the mill. I mean, the airflow is at least as crucial as the coal mass flow. I mean, we have certainly a problem to determine how much air goes into the mill, but the other thing is, do we know how much air is necessary through the mill? Now, with our new technology, you can measure airflow out of the mill, so you know what the velocities are as the mill is operating. And by that, of course, you can have a much better handle on the heat consumption, the drying process. And that itself has also, again, a big impact then on the grinding, on the fineness of what comes out of the mill.
Yeah, and coal fineness, it's critical to the combustion. I mean, the fineness is unique for each application, and if the fineness is just right, then you get that good flame impingement that you need for a low NOx burner. Of course, if the coal is being ground too coarsely, it's going to greatly affect the unburned carbon in the ash, and you can get flame impingement on the rear wall, the side walls, and all these parameters affect one another. If you're grinding it too finely, then it's going to affect that throughput. So one has to determine all these parameters and operate the mill correctly.
Yes, but the question now that we have is, what are the parameters that we should measure in order to wrap all this up? The first parameter that we have to look at is, what is the air going not only into the mill but also out of the mill? So the air balance through the mill. Secondly, you need to know the coal, or the solid mass flow balance through the mill. So you not only need to know the coal mass flow into the mill but also out of the mill, including velocities. Thirdly, you need to have a fast temperature measurement on the classifier to control the drying process to a very constant operation. And last but not least, you want to know the final product fineness, so online measurement of coal fineness. So these are the things, these four issues. This is what we want to measure online in order to optimize the performance of the pulverizer.